we will have an announcement from our SI leader. Go ahead, Malaki.
Hi everybody. I just wanted to let you guys know that I have a time and date for our SI sessions every week. So it looks like my sessions are going to be on Tuesday and Thursday from 3:00 p.m. to 4:00 p.m. Um, so those are going to be the normal sessions where I prepare material for you guys, and you can work on them together as a group, and I kind of guide you through that. Which is pretty good if you need a little bit of guidance when it comes to material. The other kind of session is the drop-in, and I'm going to be having those on Fridays from 11 a.m. to 12 p.m. Those are going to be open for you guys to come in and ask me whatever questions you need. Right, but on the other hand, I won't have any prepared material on Fridays. So I hope to see you guys at either one of these sessions. Thank you.
Okay, thank you.
Oh, reminder, they're totally optional, but you really should go. It's really helpful to spend a little bit more time with the material. Thank you.
Thank you. Okay, this SI session, even though it's optional, I strongly recommend you to join in. Okay, at least try. And again, I mentioned many times that Mr. Maldonado has been working with me for the last 1 year. Actually, in 2 weeks, that will be 1 year. So you can say that he's been working with me for for that long. Oh no, I cannot say that. It's actually start from the beginning of last spring, so it's already more than 1 year. I'm sorry. I have in mind the pandemic. The pandemic last year starts from March the 18th. So yeah, we are almost 1 year into that remote learning. Well, thank you. Well, we survived. Another announcement from me, this one is from me, that there is a quiz due this Saturday. And it requires knowledge from up to lesson 5. Okay. Don't forget, it due this Saturday. You can do most of them already even without lesson 5, but then there's the inequality part from 1.6 that we have not finished. That's the one that you need to finish that up. Please don't wait until last minute. Okay, please don't wait until last minute. And this weekend, I have like some students emailing me. One of them on Sunday, the other one, not the other one, like the other 3 was like yesterday, asking for extension. One of them because actually 2 of them quite ridiculous for me. For me, it's ridiculous. Thomas, I don't have my printer yet, so I wait until my printer arrived, and my printer arrived today. Referred to Monday, yesterday. The thing is, like I did say that for my quiz, you don't need to use printer. So if you don't have printer yet, then just write it on a paper. Okay, just write it on a paper. Now, for those, there's 1 or 2 students says that I don't have the textbook yet. Well, first, the quiz does not require textbook actually for that quiz 1. Okay, and second, if you I hope you realize that we have some students actually share with us the link to the e-textbook, right? Okay, and if you go to our files, okay, I post it there. So you have the e-textbook while you are waiting for your actual textbook. You see? So we have that. We have that here. Okay, and this is something you can download. I don't like to do this because this is actually not in line with copyright law, but I mean, at least temporarily, right? If you say that you are purchasing the book, but the book is not with you yet, then at least you have the one here that you can use. Okay, you can download this though. You can download this. Okay, at least for temporary, right? You said that you're waiting for your book. Okay, so you can use that one. You can download it and see. I actually download it, and then I see that's actually a complete textbook though. So please use that. Okay, please use that. Now let me go back to our announcement. So please use the benefit from that Mr. Maldonado provides for us. And don't forget that we have a quiz due this Saturday. Don't wait until last minute to do that. If you wait until last minute, then it defeats the purpose of me giving it to you earlier. Okay. Now the way I see is this though. If I get this kind of homework, right? I call that homework, but you can call that a quiz. I call it a quiz also in my syllabus. Right? It has some questions. So what I usually do is I print it out first, and then I see which question I can attack already. For questions that I cannot attack yet, or maybe this is the one requirement to wait up to lesson 5. Okay, but there are some problems that I can start working. Then I do that first. Don't wait until like Friday and then you start thinking about it. But Thomas, I don't have time. Blah 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 blah. Speaking about not having time, based on my background on what I learned, like not only math, I have background in business, by the way. I can tell you that most students, I'm talking about students, and most of them, when they say they don't have enough time, it's because they don't manage their time. Okay, so one way to see that you don't have enough time may be a symptoms of you didn't have a good time management. Now, I'm not saying all, okay? Some people just unintentionally have a lot of obligation. Like for example, if you are a mom and you work full time, then that's really a lot on your plate. And I can understand, even though that's the main reason I give my quiz due pretty late into the week. Okay, but if you take some classes, you don't have that much obligation, but you still feel like you don't have enough time, then take a look on your time management. Okay, one of the big issue when I myself was a student, I procrastinate a lot. Okay, good thing I have a sister, my god sister. I was adopted at some point in my life, uh, and my sister in that family told me, Thomas, the biggest problem for students actually procrastinating. So please do not procrastinate. Okay, that's the best lesson I ever had from somebody at school. Do not procrastinate. Okay, please do not procrastinate. That will be good for you. Once you know how to appreciate your own time, then you know how to use it better, and you will see what kind of people you want to deal with, what kind of people you don't want to deal with. Okay, now let's start with the lesson today, 1.6. Today the main discussion will be actually on this section though, 1.6. We're a little bit behind, just a little bit, but my assumption is that you already watched up to lesson 5. Most of the things I will go over here in this 1.6b still come from lesson 4. So the one from lesson 4 are actually this polynomial inequality and rational inequality. But I will do the absolute value inequality first. Okay, the one that I think I should do before I go to polynomial and rational inequality. Okay, to remind ourselves, absolute value inequality. if we have for a constant positive and absolute of blah greater or actually less than C implies the next line will be the blah is between positive C and that negative C. If absolute of blah is greater than C means either that blah is to the left of negative C or blah is greater than C. I'm sorry, do you think it's kind of too noisy? My background. Is it okay?
Okay.
It's okay? Now, we did this part last time. Now, let's do some quote-unquote pathological question. Number 21. Number 21. Always isolate the absolute value. Always isolate the absolute value. Now, then, suppose you already isolate absolute value, then we will see, for example, number 21, absolute of 7x plus 2 greater than negative 2. But we know absolute value is always positive, right? The absolute value is always positive. In other words, we can see this as absolute of blah is greater equals to 0, which is already greater than negative 2, right? Okay, this is always true. In other words, this is basically identity. So if we have this question, then you will say the solution will be all real numbers. Or you can say from negative infinity up to infinity. That's for number 21. Number 22, absolute of 6x minus 5 less than equals to negative 2. Now we know that absolute of something is always positive or 0, right? Now what happened here is its contradiction. You know, that's a contradiction. Okay, it's absolute of blah cannot be less than 2, less than equals to negative 2, at the same time greater equals to 0. It won't happen. That's a contradiction. Now from there we see, oh, this one has no solution. Number 23, let me do it below here. Number 23, absolute of 3x minus 9 is greater than 0. Now, this is almost always true, except that it doesn't include equal sign. Okay, we know like what I said, so absolute of blah is always greater or equals to 0. But that means either it is equal to 0 or it's greater, strictly greater than 0. Okay, strictly greater than 0. So you will see, I will do it long way first later on, but you will see the consequence. If we say this, the consequence means that blah cannot be 0. But let's take a look first. Let's take a look first. This means that 3x minus 9 is less than 0 or 3x minus 9 is greater than 0. To be more precise, if you remember this case here, the one up here, the one up here. Okay, so either 3x minus 9 less than negative 0, which is 0, or 3x minus 9 is greater than 0. Okay, but if you imagine the number line, you can just solve that too. But if you imagine number line, this is basically avoiding 0 itself. Okay, so 3x is less than 9, x is less than 3, or 3x is greater than 9, x is greater than 3. Right? So if you see the number line, this is 3 here, which you don't include, but you want everything else. Right? Okay. Basically saying that the solution will be in interval notation negative infinity up to 3, not including 3 union 3 to infinity. Okay. Now, but I honestly don't really like this solution. I prefer the second way to look at that. The second way to look at that is this. Well, if the absolute of blah has to be greater than 0, now that implies that blah cannot be 0. Which if you solve, you will get x cannot be 3. Okay, so the solution will be the same to what we have there, which we can also say all real numbers except 3. Okay, that's for number 23. Now, how about number 24? Give me a second. Number 24. Number 24, absolute of 5x plus 2 is less than equals to 0. Now that means either absolute of 5x plus 2 equals to 0 or less than 0. But this part here has no solution, right? No solution. So the only way this absolute value can happen is when it is equals to 0. But at the same time, we know absolute of blah equals 0 implies blah has to be 0. So x will be negative 2/5. Okay, number 25. We have now compound inequality. Negative 2 is less than absolute of x less than 4. Now the thing is, this part here is always true. Okay, so the only other inequality it has to satisfy is this one. And we need to solve further. In other words, this compound inequality means two things. That absolute of x has to be greater than negative 2. And you see, that's a compound inequality. Okay, absolute of x is between these two numbers. So absolute of x has to be greater than negative 2. And at the same time, absolute of x is less than 4. Now, we already said that this part here is always true, right? So I just need to solve this part. But when I try to solve that part, it turns out to be just one extra step. So x should be between negative 4 and 4. So the solution in interval notation, will be from negative 4 to 4, not including the endpoints. Okay, now even though number 25 has only one branch for us to do, but the technique actually needed for number 26. Number 26, absolute of x between 1 and 5. Like what I said before, if you see this type of compound inequality, split them first. Okay, so you will say that absolute of x is greater than 1 and at the same time absolute of x is less than 5. So if absolute of x is greater than 1, it means what? It means either x is to the left of -1 or x to the right of 1. Okay, let's picture this. So we are talking about the situation where it is to the left of -1 or to the right of 1. Let me highlight them. So the one to the left of -1 or to the right of +1. Right? That's for the first branch. For the second branch, and the absolute value of x is less than 5 means x is between +5 and -5. So between -5 to +5. Okay. So it has to be less than 5 units from origin. Okay, now you can see which part is double shaded. The one double shaded will be this part here, this part here, and this part here, right? And that is our solution. Okay, that's our solution. The solution will be from -5 to -1 union 1 to 5. Any questions so far?
Why is the first part or? So why is it x is less than -1 or greater than 1 instead of x is greater than -1 or less than -1?
Oh, because of this. If we look back, it's because of this thing. This rule here. That rule. Let me describe that even further for that context. Now, when we say absolute of x greater than 1, it means the distance of this x from 0 has to be more than 1 unit. Right?
Okay.
Okay, it
Yes.
has to be more than
Yes.
1 unit from 0. So either it is more than 1 unit to the right of 0 or more than 1 unit to the left of 0. But when we see that that graph, it implies that this x has to be less than -1 or x is greater than 1. Is it okay now?
Yes, understood. Thank you.
Okay, distance from 0 is more than 1. 1 unit to the left or to the right. Okay, that's for number 26. Now, these are problems that I left over from last Thursday about absolute value. Now I will do the hard one. Now, the following are not in our textbook. The following examples are not from our textbook, not in our textbook. But I still go over with you because it is important for your calculus analysis later on. Okay. Good thing they name it pre-calculus so that we know the aim for this course is to prepare ourselves for pre-calculus. Okay, not simply just the one in our textbook though. Now, in our calculus later on, you will see there are a lot of cases that when it comes to absolute value, sometimes you get confused what to do. Okay, me myself, when I get to my first calculus class, my calculus 1, okay, some case my instructors did this, other case my instructor did that. Now, of course, at that time, that's because there's nobody prior to my calculus class actually discussed absolute value in such a detail. Nobody. Okay, just like one instructor do it this way, or one instructor did it that another way, but nobody actually put all the technique together for us to be aware. So let's say Mr. A use the technique of, oh, you know what, absolute of x greater than c becomes what? Absolute of x less than c, what do you do? Okay, and then Mr. B, when he did absolute of x equals something, what do you do? And then Mr. C have absolute of x equals to a linear equation on the other side, then what do you do? Okay, but nobody actually summarized all these three people's doing. When I saw this, what these three people doing, I thought this way, oh, you know what? It's just different ways of doing things. Okay, but nobody really told me that actually they supplement each other. In what case do what? Okay, now the first two cases that I mentioned here, the one up here, are the easy ones. Okay, now we did problems similar to this, I think last Thursday. I think the question was like similar to this, absolute of x plus 1 equals to 2x minus 1, then what do you do? Right? Okay, that's what we did before. Now, the thing is, right now I want to go over problems that look very different from these first three cases, but the idea actually coming from there. Okay, the idea coming from there. Of course, that it requires you some background in what I did before. Okay, now the first one, what if now I have absolute of, let's say, x plus 1 is less than 2x minus 1. So remember last Thursday, we have that kind of question, absolute of x plus 1 equals to 2x minus 1. The way we solve that, one of the way to solve that is we say, if x plus 1 is greater equals to 0, okay, or in other words, x is greater equals to -1, then absolute of x plus 1 is the same to just x plus 1 without absolute sign. Now, therefore, that equation then becomes x plus 1 equals to 2x minus 1, x equals to, I'm sorry, yeah, x equals to 2. And then we confirm if x equals to 2 satisfy this. Right, satisfy that requirement that x is greater equals to -1, it is true. But then we need to look at another case. What happened if, x plus 1 is indeed negative? Which means x is less than -1. Now, if x plus 1 is negative, then absolute of x plus 1 will be negative of x plus 1. Remember the technique we had before? The definition of absolute value. Absolute of blah is blah if blah is greater or equals to 0. Negative blah if blah is negative. If that's negative, you attach another negative to make it positive. Okay, but that means that equation now becomes negative x plus 1 equals to 2x minus 1. And the boom, I will get x equals to 0. Okay, and then when I try to check with the requirement, it turns out that's not true. Okay, so the solution will be just x equals to 2. Now that's how we did that type of question before. right? Absolute of something is equal to a linear function. We have x, okay? And this is one of three different methods. So look back into my explanation at that time, okay? But this is one of three different methods. Now, what I will do here, going back to this example one, we will do it this way, pretty much, pretty similar. So if x plus 1, the guy inside the absolute value, is non-negative, which implies x is greater equals to -1, now then we will substitute absolute of x plus 1 to be x plus 1. Basically, I take off the absolute sign, which implies that inequality now becomes x plus 1 less than 2x minus 1. Okay, so x is greater than 2. Now, looking back to the requirement, the requirement is that x at least -1. Now we see that x is greater than 2. Okay, so the solution from this branch is x greater than 2. Okay, now what if x plus 1 is negative? In other words, x is less than -1. Then absolute of x plus 1 will be seen as negative of x plus 1. And that inequality now becomes negative of x plus 1 less than 2x minus 1 under the condition that x is less than -1. And then from here we go on, negative x minus 1 is less than 2x minus 1. We add 1, we add x, we get 3x is greater than 0, x is greater than 0. Now again, you compare to this requirement. You compare to the requirement, x should be greater than 0, but at the same time less than -1. But it won't happen, right? It won't happen. No, not applying. Why? Because x cannot be greater than 0 at the same time x is less than -1. So our solution for this will be x greater than 2. In interval notation, that will be from 2 to infinity. Now, let's review this question again. Look at the technique. So, why, Thomas, we need to care about that x plus 1 being non-negative or being negative? Well, because we need to think about how to get rid of this absolute sign. To get rid of this absolute sign, we need to consider when the guy inside the absolute sign being non-negative, what happened? Being negative, what happened? Okay. Now let me change the question a little bit. I change it this way. Example 2. So very similar question. The same treatment. Absolute of x plus 1 is greater than -2x plus 1. Maybe I use equal sign for sake of variety, for sake of variation. How will we solve this? The same thing. Solution. Consider when if x plus 1, the guy inside the absolute value, is non-negative, which implies x is greater equals to -1. then absolute of x plus 1 can be replaced by x plus 1 only because it's not negative. And therefore, that inequality, that absolute value can be replaced by x plus 1. Okay, so 3x greater equals to 0, x greater than equals to 0. The intersection of the section that satisfies greater equals to -1 and greater equals to 0, that's greater equals to -1, together with greater equals to 0 will give us what part? It will give us, so the solution from this part will be from 0 to infinity. Okay, but only for absolute of x plus 1 greater than equal to 0. What if it's negative? What happens if x plus 1 is less than 0? In other words, x is less than -1. Then the absolute value must be replaced by the opposite of the expression inside. Okay, and then consequently, that inequality, when it comes to this interval that x is less than -1, will become negative of x plus 1 greater equals to -2x plus 1. Negative x minus 1 greater equals to -2x plus 1. Add 2x to both sides. And then add 1 to both sides. Now then we compare with the requirement. Okay. So first, x has to be less than -1. But at the same time, it has to be greater equals to 2. Which is impossible, right? You cannot expect an x to be less than -1 and at the same time greater equals to 2. So from here, no solution. From this part here, there's no solution. Now together, when I combine this part and this part here, together we will get the solution is from 0 to infinity. So we talked about what if, what if, what if. Now the next one, the next part. Example, if I have, this one is more difficult. Absolute of x minus 1 plus absolute of x plus 3 is less than equals to, let me make it 7. Now we have two absolute signs. How do we solve this inequality? So first I will do the critical numbers. Basically, I need to consider the following. The critical numbers. This is a terminology I didn't say earlier, but I implicitly use. So we basically need to consider when x minus 1 is greater or equals to 0, when x minus 1 less than 0, right? Also, we will need to consider x plus 3 greater or equal to 0, x plus 3 less than 0. Those are the things that we're supposed to consider, right? But instead of considering it that way for now, we will do this. Solve for 0 first. Solve for 0 first. X minus 1 equals to 0 implies x equals to 1. X plus 3 equals to 0 implies x equals to negative 3. Those are our critical numbers. Negative 3 and 1. Now that tells us we have 3 regions that we need to work with. The first one is this region. That will be our case 1. This will be our second case. And this will be our third case. Those cases are when x is greater or equals to 1, when x is between negative 3 to 1, when x is less than negative 3. Okay, let's call this case 1, case 2, and case 3. Let me slow down a lot more here so that you can follow me better. I hope you can follow me in writing though. So these critical numbers help us partitioning the number line to better see the cases. Originally, you thought that we have 4 cases, right? Remember earlier I said x minus 1 greater or equals to 0, x minus 1 less than 0, and for each case, x plus 3 greater or equal to 0, x plus 3 less than 0, x plus 3 greater or equal to 0, x plus 3 less than 0. You thought that we have 4 cases, but actually no, we only have 3 cases. We only have 3 cases. Because this case, if you take a look further, you will see that this case is actually impossible to happen. X cannot be greater or equal to 0 at the same time less than negative 3. Now, instead of breaking it up this way, instead of breaking it up that way, and how about we take a look on the number line, we can see it better that, oh, we actually have 3 cases only, okay, instead of 4 cases. Now then, let's see case 1. For x is greater or equals to 1. Let me color that yellow so that you're aware we are dealing with the yellow one, so that we can keep track. Now we want to know in this interval when x is greater than or equals to 1, what will happen to x minus 1 and what will happen to x plus 3. Especially we want to know if they are non-negative or negative. Now, when x is greater or equals to 1, then x minus 1 will be greater or equals to 1 minus 1, which is 0. Now, that implies in this case, when x greater or equals to 1, we will replace absolute of x minus 1 by x minus 1, because that's non-negative. Now, what happens if x with x plus 3? Well, if x is greater or equals to 1, if x is greater or equals to 1, then x plus 3 must be greater or equals to 1 plus 3, which is 4. But that means x plus 3 is greater than 0. Right? Okay? Must be greater or equal to 0, which implies absolute of x plus 3 will also be replaced by x plus 3 only. In this first case. Now from there, then we get, oh, therefore, the original equation absolute of x minus 1 plus absolute of x plus 3 less than equal to 7 will become something like this. So 2x plus 2 less than equals to 7. Boom, x is less than equals to 5/2. In other words, when x is greater equals to 1, the answer has to be less than 5/2. Okay. It has to be greater than equals to 1, but at the same time, it has to be less than 5/2. Okay, so you see the conclusion in this interval, the solution will be from 1 to 5/2 for this interval. Let's see case 2. Case 2, when x is between -3 and 1. Again, we want to know what happened to x minus 1 and what happened to x plus 3. To get what happened to x minus 1, let me subtract by 1. So it means the other side I subtract by 1. The other side here I also subtract by 1. But then from here we see that x minus 1 is negative. Therefore, absolute of x minus 1 in this interval will become negative of x minus 1. What happened with x plus 3? I add 3 to all sides. So x plus 3 must be greater or equals to 0 but less than 4. But what I need is this part here. This is what I need. That is, absolute of x plus 3 will be replaced by x plus 3 only in this interval. Therefore, the original equation, absolute of x minus 1 plus absolute of x plus 3 less than equals to 7 will become negative of x minus 1 plus x plus 3 less than equals to 7. Okay, simplify here and there, I get 5 less than equals to 7, which is an identity, which means that the solution is all real numbers in this interval. Okay, all real numbers in this interval. So solution for this section will be, from this case 2, will be from -3 to 1. Everybody in this interval in case 2 will satisfy that inequality. Then we go on with case 3. When x is less than -3. When x is less than -3. When x is less than -3, what happened to x minus 1? And it must be less than -4, which is less than 0, right? So in this interval, absolute of x minus 1 will be replaced by negative of x minus 1. For x is less than -3, what happened to x plus 3? Then I add 3 to both sides from here. So I add 3 to both sides of the inequality. So x plus 3 will be less than 0, which also implies in this interval absolute of x plus 3 will be replaced by negative of x plus 3. Okay, now then what happened to the original inequality in this interval? I will replace absolute of x minus 1 by negative of x minus 1. Replace absolute of x plus 3 by negative x plus 3. I will get negative 2x minus 1 less than equals to 7. I'm sorry, it should be minus 2. Not minus 1, minus 2. So negative 2x is less than equals to 9. And x is greater equals to negative 9 over 2. Okay. So first the condition is it has to be less than negative 3, but less than negative 3, let me shape that, less than negative 3, but it has to be greater equals to 4.5, negative 4.5. Now that implies in this interval, this will be the solution. Now put everything together. So the solution will be from case 3, negative 9 over 2 comma negative 3. From case 2, negative 3 to 1. From case 1, from 1 to what? From 1 to 5 half. But yes, let me see, there's a check coming in. Why do we put negative 3 in case of 3? In case of which 3? X plus 3? Yeah, because when x plus 3 equals to 0, it means x is negative 3. That's the critical number. So say it this way instead. Instead of saying y for 3, we put negative 3. Okay. Why do we put negative 3 in case 3? You mean for case 3? Let me see. For case 3. For case 3, we still need to know what happened to x plus 3, right? Yeah. So it's not about when for case 3, isn't it x should be smaller than negative 3? That's right. X has to be smaller than negative 3. But at the same time, x has to be greater equals to negative 4.5. So less than negative 3, that's the green one. Okay. And greater equals to 4.5. That's how I get this. Okay. That's how I get that. Now, the thing is, if you take a look on this interval here, we can actually sew them together. We can connect them. This guy and this guy connected. This guy and this guy connected. If you take a look on the number line, that is negative 9 over 2 up to 3, negative 3. But then you connect again from including negative 3 to 1. and then including 1 to 5 half. So basically everything here, right? Basically everything there. Therefore, the solution is -9/2 up to 5/2. Now, I don't think this problem is doable other way. That's the thing. I don't think this problem is doable other way. If there's another way to do this, it will be a lot harder, more complicated. This is the easiest one. So you basically look at that case by case. Looking back, you're looking at case 1, case 2, case 3. Okay. I believe from my lesson 5, is it lesson 5? Yeah, from my lesson 5, I went over a similar question to this, a question similar to this. And I also remember I did that similar to this. No, I think it's lesson 6. Yeah, lesson 5. That's right, that's lesson 5, not lesson 6, lesson 5. Okay, now this is what I meant by, if we look back here in my structure, that's what I meant by the problems not in our textbook. Okay, that's the problems not in our textbook. Thomas, you just want to make it hard. No, 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 no. I'm preparing you for pre-calculus. Okay, this textbook is a guide, but this textbook is not what we follow. This textbook follows me. Okay, I try to work together with this book, but at the same time, I have to supplement what our textbook does not cover, but being covered in calculus. Okay, yeah. Again, the problems that we did from number 21 to number 26 require some thinking. Okay, the absolute value that we did on last Thursday tends to be just Mickey Mouse, right? The one that I went over just now, the part that I say not in our textbook, are the real pre-calculus questions. Okay, which unfortunately our textbook does not emphasize. What happens if we have variable on the other side? Okay. But Thomas, this is crazy. Well, maybe it's crazy for you. Welcome to pre-calculus, but this is not as crazy as possible. What happens if you have something square? That will be just another animal, right? Okay. So far, we have the other side has variable, but it's still just linear function. Nothing square, nothing radical, nothing rational, just linear function. And it's already complicated like this. Now, that's the first part, which I spent approximately 1 hour on, the absolute value inequality, or not in the textbook problem. Let's go on to polynomial inequality. Before I answer one of our friends' question from last Thursday, let me do number 27 first. Polynomial inequality. Now remember, every time you do polynomial inequality, once the polynomial is not linear and not absolute value, then you need to use three-step procedure. Need to use three-step procedure. I don't have better name for than this, so I would just call that three-step procedure. Okay, I learned it this way too. Okay, so Thomas, that's what you learn, and you try to project to us. Trust me, I learned it different ways also, but of so many ways that I learned, this is the easiest one to understand and to apply. At first, you may see, oh, Thomas, there's so many things we need to do. Well, trust me, it could be more. I mean, if you look at other procedure to solve this, even our textbook is a bit too long. This is the shortest one you can do. Okay, this is the shortest one. Now, I assume that you already watched my lecture from that lesson. I think that's in lesson 4 actually. But let me do, for example, number 27 first. Number 27, we have 3x plus 1 times 5 minus 10x greater than 0. No. Do not do not do the following. Then you say, oh, 3x plus 1 greater than 0, 5 minus 10x greater than 0. That's a big no-no. Let me make it a big no-no. It's a big no-no. Once you write it that way, it's just totally wrong. It's totally wrong. No, that's not how you do it. Okay? The first step, we need to find critical numbers. Now, what are critical numbers? Critical numbers are the numbers x that makes this expression on the left-hand side equal to 0. Okay, make it equal to 0. Okay, notice that I didn't say that will be the solution. That will be, how to say that, that will be, you need to be able to factor it later on. No, it doesn't have to. Problems from our textbook requires that to be factored, but no, it doesn't have to. It doesn't have to. We will see an example later on where if it is not factorable. But then if I solve this, then 3x plus 1 equals to 0, which means x is negative 1/3. Okay, 5 minus 10x equals to 0, which means x is 1/2. That's the critical number. Second, sign graph. Our textbook did what we call, that's what we call sign chart. It takes longer time. Should I do it? Can I just do it textbook method, Thomas? I can understand it better. Okay, go ahead. If you want to use textbook method, go ahead. But don't blame me if you later on say you don't have enough time. Okay. The approach is not wrong when you do sign chart, but it takes too long. It takes way too long. It takes way too long. Okay. Now the idea is this though. The reason we find the critical numbers because we want to find at what x the sign may change. That's why we call that critical number. Now from step 1, we see that the left-hand side here will be equal to 0, exactly 0, when x is negative 1/3, when x equals to 1/2. So if this is the x, this is the y. Okay, when x is negative 1/3, the y is 0. When x equals to 1/2, the y is also 0. Now, what we will do next is do testing points. Okay, do testing points. So you pick a point in this interval, let's say x equals to 0. When x equals to 0, what happened to the expression here? Okay, and we don't need that to be the exact number, which is why we just need that to be, is it positive or negative? Why we just need positive, negative, Thomas? Because later on we'll compare that to greater than 0 or less than 0, greater equal to 0, less than equals to 0. It's about 0. We compare that to 0. Okay, so we just need to know if it will be positive or negative. Now plug that number in to that expression. So 3 times 0 plus 1 times 5 minus 10 times 0. And again, you just need positive or negative. Okay, 0 plus 1 is positive, 5 minus 0, that's positive. So the product is positive. Remember I told you that negative 1/3 and 1/2 are critical numbers. Okay, what does it mean again to say critical numbers, Thomas? We call them critical numbers because if there is any change of sign, positive becomes negative, negative becomes positive, it must happen at those numbers. Okay, so when I say 1/2, x equals to 1/2 is a critical number, means there is a chance, not always, the sign here and the sign here are opposites. Okay, as we will see very soon, let's try when x equals to, let's say when x equals to 1. That's to the right of 1/2, right? So 3 times 1 plus 1 times 5 minus 10 times 1. 3 times 1 plus 1, that's positive. 5 minus 10, that's negative. The product is negative. See? Okay. So when we say 1/2 is a critical number, it means there is a chance that the sign to the left of 1/2 is different from, is opposite to the sign to the right of 1/2. Now notice that between 0 and let's say 0.1, which is less than 1/2, between x equals to 0 and x equals to 0.1, there is no critical numbers. Now, since there is no critical number between 0 and 0.1, then there should not be any change of sign between when x equals to 0 and when x equals to 0.1. In other words, you can choose any number between negative 1/3 to 1/2 besides 0, as long as it is in that interval. Okay, let's say you pick 0.1, right? And then you put that into this expression here, which is coming from here. If you put it in there, then the sign will be the same sign to when x equals to 0. Not necessarily exactly the same number, but it will be both positive. Why? Because there's no critical number in between. There's no critical number in between. Okay? And you see that between x equals to 1 and let's say x equals to 5, there's no critical number, right? Okay. Though, so we know for sure when you plug in x equals to 5 instead, you should get the same sign. We should get the same sign because between x equals to 1 that you test earlier and x equals 5 that we test just now, there's no critical number. Therefore, in this interval here, all of them will be negative. Okay, that's why we call that critical number. The reason we call something critical numbers because there's possibility a change of situation at that moment. Okay, when we say Thomas is critical, okay, Thomas is currently in critical situation, you know that he's about to die. That's what it means. Or Thomas is now in critical moment. Oh, then you know, oh, well, he possibly died. Now, when we say critical, doesn't mean Thomas will die. No, okay. We say critical that there's a possibility that Thomas will die. Okay. Now, and of course, critical moment doesn't have to be in the negative sense. For example, me getting married, that's also my critical moment. Okay. Before I get married, I live for myself, right? Whatever that means. Okay, I spend my money my way, I gamble my money away, that's my problem. But once I get married, that change. Okay, that may change, to be more precise. That may change. Okay. But you don't expect me to have a certain behavior today and without critical moment in between, and all of a sudden tomorrow I totally changed to someone I was not before. No, you need some critical moment. You need some critical moment in between to change you from someone like in A type becomes B type. Okay. Now, that brings us a life lesson though. You want to improve, give yourself some critical moment. Challenge yourself. Challenge yourself. Okay, now we test this coordinate, the point here. The point, pick an x to the left of -1/3. Let's say I pick -1. You can pick -2, as long as it is in this interval, as long as it is in this interval. Okay, and we don't care about what's the result if you put that into the expression. What's the number? We just care about, is it positive or negative? Okay, this will be negative here. -3 plus 1 is negative. 5 plus 10 is 15. That's positive. So the product will be negative. Let's review. Let's review. So first we get the critical numbers. Those are the numbers that tells us where there possibly a change of sign. Now then, once you get the partition, you test each interval. Just randomly pick any x you like in that interval and test the sign. See if that's positive or negative. Therefore, you see that the other side has to be 0. Okay, so that we can just look at, is it positive or negative. Then step 3, the conclusion. The conclusion, we need something positive greater than 0. Okay, we need something positive greater than 0, strictly greater than 0 instead. Okay, so the solution will be, look at that sign graph, look for the interval where the sign is positive. And you will see it's from -1/3 to 1/2. Okay, these are the 3 steps. First, critical number, second, sign graph, third, the conclusion. Okay, that's for number 27. Let's see number 31, the question from one of our friends from last Thursday. I hope that student can do that already at this point, but if not, then it's still, you can understand it now. Now remember that the other side has to be 0. Okay, so what I will do is I distribute that x first and subtract by 5 such that the other side is 0. Now this way then, later on, we can just look at the positive, negative, right? Then from there, I do the critical numbers. Step 1, critical numbers. And I want you to specify step 1. I need you to write that 1. 1, critical numbers. 2, sign graph. Okay, so you know which part you are actually working on. Okay, and please do it this way because we will use this template again somewhere in chapter 3 or chapter 4. Okay, let me, for critical numbers, I set this equals to 0. Okay, don't keep that greater equal sign. No, set it equals to 0. And I believe this is preferable. So we get x is -5/2, x equals to 1. Then I do sign graph. Plot that those critical numbers, -5/2, which will make that expression equal to 0. And x equals to 1, which is also make the expression equals to 0. I refer to this expression here. I refer to this expression. Now then, let's pick testing point. Here I have x equals to 0. Right? So when x equals to 0, plug that in. Basically, you plug that in here when x equals to 0. Okay, but sometimes it may be helpful for you to look at this. When x equals 0, this is positive, this is negative. You see that? Okay. After all, we already factor it, right? So you can use the factored part. But if you don't want to use the factored part, you plug x equals to 0 here. You see negative 5, right? So you know that's negative. Now, what happened when x equals to, let's say, 3? Can I use x equals to 2 times? Yes, you can. Yes, you can. When x equals to 3, I plug that into that 2 times 3 plus 5 times 3 minus 1. Again, what I need is just positive or negative. This is positive times positive. So the product is positive. How about the one here? Can anybody help me? What number will you choose as your testing point here in this interval? Anybody? Can you pick a number less than negative 5 half? That's negative 2.5. So what can you pick a number less than negative 2.5? Okay, nobody's telling me anything. So, well, I tell you then, you can pick negative 5, maybe. You can pick negative 3, that will do, as long as it's less than to the left of negative 2.5, negative 3. Then you plug that negative 3 into either the factored form or the one before you factor. Okay, just make sure that the other side has to be 0. So 2 times negative 3 plus 5 times negative 3 minus 1. 2 times negative 3 plus 5 is negative 1. Negative 3 minus 1 is also negative. The product of two negative is positive. Then we look back, which sign do we need? Do we need positive or 0? Oh, we need positive or 0, greater or equals to 0, right? Positive or 0. So look at that sign graph. Look at that sign graph. Which interval will give you the positive or 0? The positive will be in this interval, but I will include the 0. Okay? The positive or 0. So conclusion, the solution will be from negative infinity up to negative 5 half, including negative 5 half, because that will give us the 0, and then from 1 to infinity. Okay, that's for this question. Let me zoom it out a little bit so that you can see better. That's the question. A critical number, sign graph, solution. And you will see you spend a bit more time in the sign graph, but once you get used to it, so make sure you practice that at home. Then on Thursday, I will give you a little secret on how to do it faster. Okay. Now, the thing is, our textbook does not have a question, what if the expression is not factorable? Remember, I told you that our textbook used the sign chart method. Okay, our textbook used the sign chart method. That method works very well, and actually works only, it works only the expression is factorable into linear form. Only works if this expression here, this polynomial, is factorable into linear forms. Mx plus b, mx plus b. Now, what happens if they are not factorable in linear form? Then that method will not work anymore. Okay, so if I want to say the method they show you in this chapter 1, it's not wrong. They are reviewing from Algebra 2. But what I am trying to do is, instead of sticking with Algebra 2 method, we go to more general method. Okay, that's why I don't do sign chart, I do sign graph. Okay, and when you go to Calculus 1 later on, you will do a lot of sign graph again, not sign chart. You will do a lot of sign graph again. Okay, now let's take a look, for example, this question. So let me go back to normal view, 100%. Okay, what if the other side is not factorable? So for example, we have 2x squared minus 5x greater equals to 4. The other side has to be 0. That is always true. Okay, then I do the critical numbers. I set it equals to 0. Now, if you have the mindset that it has to be factorable, then you will see you get stuck here. Because this is not factorable. But remember, our goal is not to factor it. Our goal is actually solve it. Okay, so besides factoring, we can solve it other way. In this case, we can use formula. So the discriminant is b squared minus 4ac. That is 25 plus 32. Such that the solutions are x12 equals to negative b plus minus square root of 57 over 2a. Okay, so the critical numbers are 5 plus square root of 57 over 4 and 5 minus square root of 57 over 4. Now you can use your calculator to estimate, but the estimation will only help us to pick testing points later on. So let me do the sign graph first. Sign graph. So 5 plus square root of 57 over 4 and 5 minus square root of 57 over 4. Those two are the zeros. Okay, now then I want to pick a number here. I want to pick a number here. Oops. I want to pick a number to the right of this 5 plus radical of 57 over 4. What number should I pick? Now, I don't think I can pick any number until I know What is this approximately, right? Then you use your calculator to compute that just to get the approximation, but do not change that into decimal. Okay, 5 plus square root of 57 divided by 4, that will be 3.1 something. So let me choose x equals to 4. Okay, now when x equals to 4, plug that in here. When x equals to 4, plug in there. So 2 times 4 squared minus 5 times 4 minus 4. That will be 32 minus 20 minus 4. That's 8. So that's positive. Okay, again, this is approximately 3.14, approximately. Okay, let's see what is this equal to. 5 minus square root of 57 divided by 4. That's approximately negative 0.6, approximately. Now, do not change that to negative 0.6. Do not change it to 3.14. The critical number still these two numbers. Okay, the critical numbers are still these two numbers, and not this, not this. Okay, so what is the purpose you get the decimal timers? So that I can pick points. If I want to pick a number in this interval, I need to know approximately what number is this, approximately what number is this. Okay, now from here we know that I can pick x equals to 0. So when x equals to 0, 2 times 0 squared minus 5 times 0 minus 4, that's negative 4, that's negative. And then for the one here, I can choose x equals to, let's say, negative 2. Why not? So 2 times negative 2 squared minus 5 times negative 2 minus 4. That's 8 plus 10 minus 4. That's 14. That's positive. So you see that we still can solve this even though the expression on the left-hand side is not factorable. Okay, then we look back, what we need? Oh, we need greater equals to 0. So positive or 0. Positive or 0. Okay, positive or 0. So step 3, the solution will be from negative infinity up to 5 minus square root of 57 over 4 union, oh, I'm sorry, not parenthesis, should be bracket, because we include the 0. Union 5 plus square root of 57 over 4 to infinity. Okay, now I will leave it here so that you can take a look during our break. Let me zoom that out a little bit so that you can see better. Okay, we will come back at 9:40, make it 9:41. Come back at 9:41. Now we go on with the third part of this section 1.6 on rational inequality. In this rational inequality, in solving rational inequality, we still need to use three-step procedure. In fact, when we try to find the critical number in critical number part, in step 1, we need to incorporate the x's that make the rational function or rational expression to be undefined. Okay, we need to incorporate those x's that makes the rational function to be undefined as also as critical numbers. Okay, now, for example, on that 1.6 part, let's see which question I want to do. Let's see which question I want to do on the top. Number 42 and then number 36 and then number 48. Number 42 first. Number 42. We have 5x over 16 minus x squared less than 0. Okay, step 1, critical numbers. Okay, 5x over 16 minus x squared equals to 0. Either 5x equals to 0 or x equals to 0. That will, I'm sorry. Yeah, 5x equals to 0 means x equals 0. That will make it 0, right? Okay, but the denominator, let me factor that first so that we can see it better. Let me factor it first. So this is 5x over 4 plus x, 4 minus x. So the critical numbers from the top is 0. The critical numbers from the bottom is x equals to -4, x equals to 4. Okay, so you see what we call critical numbers here will be the one that make it equals to 0, right? But also the one make it undefined. Okay, that's what I meant here. That's what I meant here. On the top of the zeros, when we solve equals to 0, right? The solution for that equation as the critical number, we also incorporate those that makes the rational numbers to be undefined as critical numbers. Okay, now then we go on with our sign graph. Let me do it here just to save some space. To sign graph. The critical numbers are -4, 0, 4. Okay, when x equals 0, that expression becomes 0. I meant this expression becomes 0. However, when x equals to -4, the expression becomes undefined, not 0. Okay, that's also undefined. Now we do testing points. Okay, now we do testing point. Let's say x equals to 5. When x equals to 5, then we will get on the top, that will be 5 times 5, that's positive. At the bottom, that will be 4 plus 5, that's positive. And then 4 minus 5, that's negative. I plug that in here. You can plug that in here too, because they're just the same expressions, right? Now, then between 0 and 4, let me choose x equals to 1. So 5 times 1 is positive, 4 plus 1 is positive, 4 minus 1 is positive. So the product and quotient overall is positive. And when x equals to -1, 5 times -1 is negative, 4 plus -1 is positive, 4 minus -1 is still positive. So the boom, that's negative. When x equals to -5, 5 times -5 is negative, 4 plus -5 is negative, 4 minus -5 is positive. That's positive. Then in our step 3 solution, so we need the ones that is less than 0. Oops. We need the one that is less than 0, which means it's negative. We need the negative part. You see that? So the idea is exactly the same to what we did before in polynomial. The new stuff right now is we have new category of critical numbers. Okay, but the techniques still exactly the same. Okay, so from here the solution will be -4 to 0, and then from union 4 to infinity. Okay, that's for number 42. Is there anything new? Yes, we have new type of critical numbers, but overall the procedure is still the same. Any question? Oh, okay, number 38. Is it 38 or 36? Which one I want to do? 36, not 38. Which means I did number 38 already in my lecture. Now I do number 36. If I have x squared plus 1, x minus 3, x squared minus 9, greater equals to 0. It's already greater equals to 0 on the other side. So critical number, I set it equals to 0. X squared plus 1 times x minus 3 over x plus 3, x minus 3. Don't cancel that. Don't cancel that. Is the answer for number 42 that one? Yes, I remember, yes. Yes, I remember, yes. Yes, that's the solution. So -4 to 0, union 4 to infinity. Okay, now let's go on. Now, here we have common factor that you tend to cancel, okay? But don't cancel it though. At least it has to, it still, x equals to 3 will still be a critical number. Okay, x plus 3, x equals to 3 is still a critical number. So don't cancel it, don't cancel it. Okay, leave it there. Now we will get critical numbers, x equals to 3, x equals to -3, and also x equals to 3, but x equals to 3 is critical numbers on the top and at the bottom, therefore it happens twice. Now how about this guy Thomas? The thing is, this will never be 0. X squared plus 1, x squared plus 1 equals to 0, x squared equals to -1, no solution, right? So there's no critical number from that factor. Okay, we have only 2 critical numbers here. Step 2, sine graph. I purposely do it sideways so that I can fit into this one screen here. But when you actually do it in your test, the second step usually at the below step 1. When I do the sine graph, I get -3 and 3. When x equals to -3, it is undefined. What happened when x equals to 3? What happened when x equals to 3? When x equals still undefined. It's 0 on the top, but also 0 at the bottom, right? Okay, 0 over 0 is undefined. Okay, now then I do testing point. When x equals to 0, when x equals to 0, I will get on the top, I get positive times 0 minus 3, that's negative. At the bottom, I get positive times negative. Oh, that's negative. That's positive. Huh? So yeah, that's positive. What happened when x equals to 5? When x equals to 5, the top left, x squared plus 1, still positive. 5 minus 3 is positive. 5 plus 3 is positive. 5 minus 3 is positive. That's still positive. Okay, I can give you a little glimpse of the cheat, the shortcut. Notice that this x equals to 3 is a critical number with even multiplicity. The exponent on the top is 1. The exponent at the bottom is also 1. The total of 2, right? Now, if that critical number comes from even multiplicity, it happens twice in short, then there will be no change of sign. If the multiplicity is even, let's say the power is 2, or in this case, the power is 1 on the top and 1 also at the bottom, okay, then it is even multiplicity. Then there will be no change of sign through that critical numbers. Okay, while x equals to -3 is a critical number with odd multiplicity. The exponent is 1. Now, if the exponent is 1, you see the invisible 1 here. That's what I meant. Because the multiplicity is 1, then there will be change of sign. So it will be negative here. Now, if you don't believe that, of course you can check x equals to -5, let's say. Okay, that will be positive here, negative here, negative here, negative here. Does it make sense? Okay, so one way you will see, if once you do more example using this, the testing points, then you will see that phenomena that if the critical number is even multiplicity, in this case, 1 on the top, 1 at the bottom, the total of 2, right? Then there will be no change of sign. The sign on the left-hand side and the right-hand side must be the same. Okay, and then x equals to -3 is a critical number with multiplicity of 1 only. Therefore, there will be change of sign. Okay, now that will help us with our computation faster later on. So what's the solution? We need that to be positive or 0, but no 0 here. So the solution will be from -3 to 3 union from 3 to infinity. Okay, that's for number 36. Last problem from this section, and therefore we are done with chapter 1. We spent 2.5 weeks, 5 meetings just to do chapter 1. These 6 sections, and even that, I actually skipped 1.5. Okay, basically I try to fix whatever weakness you have before pre-calculus plus material from pre-calculus, such that we never need to worry about solving equation or solving inequality anymore. Number 48. number 48. Now set one side equals 0 first. Set one side equals 0. So let me do it this way. I will subtract by 3 over x plus 2. Okay, and then I will simplify my left-hand side, make it into one fraction. So the LCD is 2x minus 1, x plus 2, right? So on the top left becomes x times x plus 2. The top right becomes 3 times 2x minus 1. Can you follow me? And then I simplify the top, I will get x squared plus 2x minus 6x plus 3 over 2x minus 1, x plus 2 greater equals to 0. So I get x squared minus 4x plus 3 over 2x minus 1, x plus 2. Okay, so one side already 0 and the other side only one single rational expression. Not two terms, not two terms. Not two terms. Not two terms like this. If there are two terms, then put them together into one fraction. Now from there, then you start your step 1, 2, 3. Okay, from there, then we start our step 1, 2, 3. So let me do it here. What is my step 1? Critical numbers. X squared minus 4x plus 3 over 2x minus 1, x plus 2 equals to 0. Factor the top. The bottom one already in factored form. So the critical number on the top are x equals to 3, x equals to 1. At the bottom, x equals to 1/2, x equals to -2. And notice that all these critical numbers has multiplicity of 1. Has multiplicity of 1. The exponents are all 1, right? And there's no repeat on the top or with the bottom. Okay, those are our critical numbers. Then when we do the sign graph, that will be a lot faster. When we do our sign graph, the critical numbers are -2, 1/2, 1, 3. It will be undefined at -2 and 1/2. Will be 0 at 1 and 3. Now, let me pick a testing point. Let's say I pick x equals to 0. I will test it to this, which is basically the factor form of this, right? That's the factor form of that. I plug that in there. Okay, I plug x equals 0 to that. Then I will get -3, which is negative, -1, which is negative, -1, which is negative, +2, which is positive. The overall product and quotient will be negative here. Any questions so far? Because from here it will go fast. Do you remember that we spent so much time on sign graph before? Right now, with the idea of multiplicity of the zeros, right, or the multiplicity of the undefined, then we can do this a lot faster. Notice that I said earlier, the multiplicity for each one of these are 1. Why? Because the exponents are all 1. Okay, and there's no repeated zeros on the top and the bottom. Now, it means each critical numbers will change the sign once we cross that critical number. In other words, when I jump here, I will change the sign. Why? Because x equals to -2 is a critical number with odd multiplicity, with multiplicity of 1. When I jump across this one, also multiplicity of 1, I change the sign. Jump this, still multiplicity of 1, I change the sign. Still multiplicity of 1, I change the sign. So instead of having 5 testing points, I do only 1, and I use the idea of multiplicity to jump across that critical numbers. Now then, I go back to this. I need to have greater equals to 0. Greater equals to 0. That will be for our step 3. So we don't worry about the inequality until the last step. The first step is just you set it equals to 0, solve for the critical numbers that make it 0 or make it undefined. Second, you do the sign graph. Now, when you try to do the sign graph, you can take advantage of the fact that the sign will change across a critical number that has odd multiplicity. Okay. Again, if you don't know this, if you still don't get it, just do testing point for each. Okay, but you still need to do 4 more testing points. Okay. Now then, step 3, I need greater equals to 0. So the solution will be from -infinity up to -2, not including -2, union 1/2 up to 1, not including 1/2, but including 1. Then union including 3 to infinity. Okay, so you will see actually the part that you have here takes you longer time if you really used to do these steps here. Okay, now one big warning, but very big warning. When we try to solve a rational equation, when we try to solve this, we multiply by the LCD. So we get x times x plus 2 equals to 3 times 2x minus 1. Okay, that's what we did at that time. But why don't we do this here? Don't we multiply by the LCD? When dealing with rational inequality. In other words, why can't we do it this way? X over 2x minus 1 greater equals to 3 over x plus 2. Why don't we multiply this? Why we are not allowed to multiply by the LCD? Why can't we multiply by the LCD? And the reason is because we don't know if 2x minus 1, x plus 2 that you try to multiply by is positive or negative. When it is equal, it doesn't matter. But when it is inequality, then it does matter. Why? Because if it's positive, then you need to keep inequality sign if that's positive, right? Okay. But if that's negative, you have to reverse the inequality sign. So do you keep it or do you reverse it? We don't know. That's why we can't use this method. Okay, that's why we can't use this method. Okay, that's the explanation. Why don't we just multiply by the LCD? That's how we did it before, Thomas. And Thomas, by the way, you did mention something before saying that solving equation is very similar to inequality. No, that's not what I say. You can see my recording. I didn't say solving equation is very similar to solving inequality. What I said was solving linear equation is very similar to solving linear inequality. But that's not for polynomial inequality. That's not for rational inequality. Only for linear inequality. Okay, not for polynomial, not for rational, not for others. Only linear inequalities can be solved very similarly to linear equation, but not for other cases. Okay, so I'm done with this chapter 1. Okay, let's go on to 2.1. Just a little bit more. I'm for sure cannot go on with 2.3 and 2.2. Let me delete this with the time I have left. I don't think I can do this, but I think I still can go over 2.1. We did 2.1 already, actually. If you take a look on that section, 2.1 is about midpoint formula, which we did on the first lesson, and distance formula, which we also did in the first lesson. Okay, so my assumption is you already know midpoint formula and distance formula. So what are the problems we need to do here, Thomas? The problems we need to do here are basically the combo of midpoint formula, distance formula, solving equation. For example, number 23. Number 23, the question is find the formula or the equation that expresses that pxy is, so pxy in that formula is perpendicular bisector line of AB. The A is -4, -3. The B is 6, 1. Okay. Now I will do this first without background in geometry, and then second with background in geometry. Solution. First, without background. If you forget your geometry, then we need to do other work. The storyline is basically as the following. Suppose I have point A here and point B here. Can you find all those points whose distance from A and from B are the same? Can you find all those points, let's say this point here, whose distance from A and from B are the same? Okay. In other words, if we follow the direction from that question, find all those P's such that AP, this segment here, is congruent to DP. Okay, we are looking for the equation or the formula for all such P's. Okay, now they give us a hint, call that P x comma y. Call that P x comma y. Our A is -4, -3. Our B is 6, 1. Okay, so basically I need to find those coordinates P, X, Y such that the distance from A to P is equal to the distance from B to P. Okay, now the distance from A to P will be x plus 4 squared plus y plus 3 squared. How do you get that, Thomas? X minus x1 squared plus y minus y1 squared. Okay, while on the right hand side, we have square root of x minus 6 squared plus y minus 1 squared. And then you basically need to solve this. Okay, you basically need to solve this equation, and you'll get it is equation of this line. You will get the equation of this line. Okay. You will get a linear equation, and when you try to sketch that line, it will be that line that I'm marking blue, highlight in blue. Okay, now this is a thing that I say that once we set it up, I assume you can solve it. Okay, now let me just do it super fast, okay, without trying to skip any steps, so that when you read that again, you know what I'm doing. So what I will do is I will FOIL it. On the right hand side also. And then combine like terms, x squared plus y squared plus 8y plus 8x plus 6y plus 25 is equal to square root of x squared plus y squared minus 12x minus 2y plus 1. Now I will square both sides. Equals to, so basically you see I cancel the square root, right? And you can see x squared, y squared cancels. So I will get 20x plus 8y equals to -24. No, I can reduce by 4. If I reduce by 4, that's 5x plus 2y equals -6. Am I computing anything wrong? Oh, I'm sorry. This should be 37. 37. So when I subtract, that will be 12. That will be 12 here, divided by 4, that becomes 3. Okay, that's if you do it without background in geometry. What happens if you have background in geometry? Which is actually prerequisite for this class. If you have background in geometry, then we know the following, that the perpendicular bisector of point AB will be perpendicular bisector of that segment, and perpendicular bisector of that segment must be this line L. Now this line L contains the midpoint of AB, right? Okay, so let's find that midpoint first. So the midpoint for AB is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that will be 2 over 2, that's 1, negative 2 over 2, that's negative 1. Okay. Second, the slope of this line L, must be negative reciprocal of the slope containing AB. Okay, because it's perpendicular, right? Okay, so let's find the slope of line AB containing AB. That will be y2 minus y1 over x2 minus x1. So that's 4 over 10, that's 2/5. So the slope of that line L will be negative 5/2. Now we go on then. So what is the equation of that line L? Y equals to negative 5/2 x plus b, and I plug in coordinate 1, negative 1. So negative 1 plus 5/2 is 3/2. So the equation of the line will be y equals to negative 5/2 x plus 3/2, which if I multiply by 2, give me 2y minus 5x equals to negative 5x plus 3, and then I move the 5x to the other side. It gives us the same answer we have on the top. Okay, totally different approach. Okay, totally different approach. Now that's for number 23. If you see a totally different approach and you see the difference we have if we consider your background in geometry or if you don't have background in geometry. In the next 5 minutes, let me do one more problem, number 28. That's actually on the easy side. Number 28. Find all points on the x-axis that are distance 5 from P to negative 2, 4. Okay. Solution. Let x comma 0 be a point on x-axis, right? It's a point on x-axis, so that point must have y equals to 0. Now, then the distance squared from this point to P, so x minus x1 squared plus y minus y2 squared should be equals to 5 squared. You solve for this. So what I want to say is like, you need to know how to let those coordinates first, define your coordinate, call that x equals to x comma 0 because it's on x-axis. Plug that into distance formula. Okay, plug that into distance formula and solve. Basically, you will solve that last equation. Okay, that will be 25 equals to x plus 2 squared plus 16. Let me continue here. So x plus 2 squared equals to 9, x plus 2 equals to plus minus 3, x equals to negative 2 plus minus 3. We are not done yet. Because the questions are, what are the coordinates? So you need to write your final answer in coordinates. So the coordinates are 1, 0 and negative 5, 0. Okay, that's where I will start. I think I will do number 29 at a time. Yeah, I will do number 29 on Thursday then. Yeah, I will do number 29 on Thursday. So what I will do on Thursday, I will do a lot. On Thursday, I will do number 2.2, 2.3, and then 2.2, and then 2.5. Okay, so on Thursday, I will do 2.3 and then 2.2 and then 2.5. I will post a graphing paper for you to print out, but you can get your own graphing paper, but bring graphing paper for sure. Okay, bring graphing paper on Thursday. We will start graphing some basic functions. Okay, bring or print graphing paper. I will post the graphing paper on your discussion board today. Okay, then that's for today.
Oh, just a second.